Okay, so going to have a look here at 2009 6C. So I'm told straight chain molecules of C13, H28 occur in the kerosene fraction. Upon cracking, I'm told I have a molecule of C2H4, a C4H8, and I'm told then I have an unbranched alkane. And I'm asked to identify this and to state its octane number. So I've started off with C13H28. We don't even need to draw this because we're told, we're not asked to make up the three fractions that are produced. So I've taken away C2H4. So that leaves C11H24. So that's the C2H4 gone. I'm then told I have C4H8 also made. So that's C7H16. So that's that gone. So my unbranched alkane is C7H16. So 7, that means it's heptane. And that has an octane number of 0. Remember that, and 2,2,4-trimethylpentane are my reference hydrocarbons. Heptane has an octane number of 0. 2,2,4-trimethylpentane has an octane number of 100. The next thing then that we're asked, which I think is really where the basis of the question came from, is draw the three structures for the isomer C4H8. Okay. Firstly, here we have to recognize that it is an alkene, okay, so C4H8. So 1 means it has one double bond along its chain, 3, 4 carbons. 1, 2 hydrogens, I can't put in any more because a carbon can only take 4 bonds. Likewise, 1, 2, 3, 4, 1, 2, 1, 2, 3. So if I just count my hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. That's my first one, bute, and my double bond is on my first carbon when I number from left to right. The second structural isomer I have again is quite similar, except I'm going to have to put my double bond on my second carbon. So if I look here, that's 3 hydrogens. I have 1, 2, 3 already in carbon bonds, 1, 2, 3 as well in carbon bonds, and then 3 here at the end. So again, 1, 2, 3, 4, 5, 6, 7, 8. But this time, my double bond is on my second carbon. So that's going to be but2-ene. Remember, an isomer is the same molecular formula, but a different structural formula. The final thing then that I'm going to do is I am going to take off a CH3 methyl group. So when I do that, that CH3 methyl group is always going to attack into one of my middle carbons. Remember, if it just goes on my first or my last carbons here, again, it's just going to create a straight chain. So I have 1, 2, 3, and in my middle carbon, I have my CH3. So 1, 2, 3, 4, and I have 1, 2, 3. Okay, so just if I count again, 1, 2, 3, 4 carbons, 3, 4, 5, 6, 7, 8. Okay, propene, meth, eth, prop, so that's propene. And numbering left to right or right to left, 2-methyl propene. Just a little note that 1, 2, 3. And if I put my double bond here at the end, and I know we looked at this in class, this would also be but1-ene because you number, so the double bond occupies the lowest available carbon number. Okay, so just be aware of that but3-ene doesn't exist. So they are your 3 structural isomers, but1-ene, but2-ene, and 2-methyl propene.